Greetings. Thank you for watching, and many apologies for the delay in making a new video. I have been swamped in work, but I decided to find a little time for this new video. Today I wanted to tell you about this book. It's a classic published by Wiley Publications in Statistics. Can you guess what it is? Famous Stochastic Models for Learning by Bush and Mosteller. And this clearly was once in a library collection, specifically at Northern Michigan University. I didn't steal it, of course. I bought it used. I don't remember where or when, but there it is. And it even has the thing here to keep track of the borrowings, and there are some interesting 1958, 1966, 1970, which is interesting. There are no names though. Anyways, so this is a classic in learning theory, and it's quite a thick book, and it was published in 1955. And the preface, the very first assertion in the preface goes like this: mathematics is often regarded as a science, but to do so is an error. Oh. Science is concerned with the empirical world, whereas mathematics is the study of relationships among empirically undefined quantities. The bridge between pure mathematics and empirical science is the identification of mathematical constructs with observables. When such identifications are made, we shall say that we have a mathematical model of a situation. There's a lot there to think about. So that's the preface, and of course it is famously a very mathematically oriented book. Of course, it has, in addition to a preface, it has an introduction, and they start the introduction this way: in the construction of mathematical models, there are usually three main steps or levels. One, the mathematical system. Two, the identifications of or coordinating definitions. And three, the specific applications. And they elaborate each one of those steps or levels. And of course, the introduction is a little bit longer than the preface, as it should be, as is often the case. And they proceed in chapter 1 with the basic model. So it's a book about apparently a single model, one model. Okay? And something very interesting is that one of the central concepts of the basic model is the concept of a response class. Okay? Now, they are classes understood as sets in the technical mathematical sense of set theory. Okay? So, and of course, this doesn't surprise because their model is stochastic. Okay? And although they speak in the plural here in the title, stochastic models for learning. So I'm not sure if it's just a single model or several models. The title of chapter 1 is the basic model. So I'm not sure exactly how that works here. But the concept of a response class understood as a set is crucial because of the stochastic character of the models, which is to say probabilistic models. And as I'm sure many of you know, set theory is central is at the core of probability theory. So that's also interesting. And then it gets very quickly, very, very mathematical, very technical. And it goes on and on and on with equations and a lot of them. And so matrix operations. So it's a very nice book to have a good training in mathematical modeling for learning. And the table of contents. In the table of contents, we find the following titles of for chapters. For example, chapter 2 is called Stimulus Sampling and Conditioning. So this is a stimulus sampling approach. Sequences of events. Chapter 3. Chapter 4, distributions of response probabilities, and so on and so forth. This is a very, I would say, behaviorally oriented book or approach, in the sense that the emphasis is on response probabilities, on response frequencies and response classes, and it doesn't seem to postulate the kinds of cognitive entities that are usually found in other computational models of conditioning. So there you go. That's stochastic models for learning by Bush and Mosteller, 1955. Take care until next time.